So the question is, a block is pushed momentarily along horizontal surface with an initial velocity v. Coefficient of sliding friction is mu and the block will come to rest after time. So we need to find the time after which the block will come to rest. Here a block is moving on a rough surface. Okay, so the surface is rough. How do you understand that? Because the coefficient of friction is given. That means mu is not is equal to 0, right? Mu have a value, right? So the friction coefficient of sliding friction is mu, that's given. So the surface is rough and the block is moving with an initial velocity v. We need to find the time when the velocity, final velocity, becomes 0. That means the body come to rest. So here the body is coming to rest after some time. So we need to find this time. And according to Newton's first law, there should be an external force on a moving body in order to make it stop. So there is an external body which causes the motion of the block to stop. So the block is moving this side and let the mass of the block be m with a force. The block is moving with a force ma. This is the applied force, okay, and the force acting against the motion is actually the frictional force. Okay, so a frictional force acts against the motion of this body. So in order for the body to stop its motion, the applied force and the frictional force should be equal, right? So we know that the equation for the frictional force, friction F is equal to mu into m into g. Okay, so from this we can conclude that ma is equal to mu into m into g, right? So this m on the both side of the equation get cancelled and we get that a is equal to mu into g. Okay, and we know that from the equations of motion v is equal to u plus a t. Okay, here the final velocity v is equal to 0 and the initial velocity is v, plus a is mu into g, right, and time t. Okay, and the one thing that you need to realize is that the body is moving this side with an initial velocity v and the body is coming to rest. This means that body is not accelerating, the body is decelerating, or the body is undergoing retardation. So we need to give a negative symbol to the acceleration. Okay, so this acceleration is actually minus at in this equation. So we will have to give the same symbol here also, and taking this v to the left hand side of the equation, we get minus v is equal to minus mu g into t. On cancelling this negative signs on the both side, we get time t is equal to v by mu into g. This would be the time required by the body before coming to rest. That is actually option A. Hope you understood.